Now we have a little more complicated fraction. And if you recall, earlier in the notes, we talked about the rules that you wanted to follow when doing integrals with fractions. And the first one was negative exponents. That's not going to apply here. But the next one you were supposed to look for was, I believe, a du over u. And as long as the top is the derivative of the bottom, then the integral is the natural log of absolute value of u plus c, as long as that is that way. So if we look at the bottom, x cubed plus 2x, the derivative of x cubed plus 2x is 3x squared plus 2, so this is really the integral of du over u, which means it's going to be the natural log of u. And u, of course, here is the bottom, x cubed plus 2x. So ln of x cubed plus 2x, absolute value, plus c. And then the next one is the tangent of x. Well, we have no trig function that we take the derivative of to get tangent. So the only way to do this, and I will tell you right now, this is on every test I've ever given over this section, the integral of the tangent of x, and every year kids miss it, which is a shame because I always have it in notes as well. The only way to do it, you have to make that the sine of x over the cosine of x dx. Now, look at this. The denominator is cosine of x. So is that a du over u? Well, if u is the cosine of x, then du dx would be negative sine x, which means that du would equal negative sine x times dx. Unfortunately, I don't have a negative sine x dx. I have a positive sine x dx. So one way you can fix that is to simply make it a negative sine of x. But if I do that, I need to put a negative out in front of the integral. And of course, a negative times a negative, or the opposite of a negative, is positive. So I haven't really changed the value of my integral because I have two negatives, but I do have a negative integral of du over u. The du is negative sine x dx, which you can see we have right here. And the u is the cosine of x. Du negative sine x dx. So since that's what I have, I can simply say this is equal to the opposite of, and then that integral is going to be the ln of u, which is the ln of the cosine of x, and then plus c. So that's a little trickery there that you're going to have to learn how to do. All right, let's take a look at the next one. Because that's x to the fourth and that's x to the third, looks like we might have a shot at having the top be the derivative of the bottom. So if the top is, if the bottom is x to the fourth plus x squared, if that's u, then du will be 4x cubed plus 2x. And that's du dx. However, if we multiply both sides by dx, then it'll be 4x cubed plus 2x dx. Well, we don't have 4x cubed plus x dx. However, what if I multiply the top by 2? 2 times 2x cubed plus x over x to the fourth plus x squared. Now, since I multiplied the top by 2 of the integral, I need to multiply the whole thing by 1/2. Now, again, you can pull that constant. Remember the rules. We can take this constant that I put here, pull it out front. Now you have 2 over 2, which is 1, and you have the exact same thing you started with. So by multiplying by 2 on the integrand and multiplying by 1/2 out front, we cancel those out. But now we've created what we want because we have the integral, we have 1/2 times the integral of 4x cubed plus 2x over x to the fourth plus x squared dx. And of course now I have basically this is 1/2 integral of du over u. So that'll be the ln of the absolute value of u, which is x to the 4th plus x squared, and then plus c. So the last one, the denominator is x squared. If I took the derivative of that, it's just 2x, and I could multiply by 2/3 and get 2x, but we have this plus 7 here that's going to mess everything up. So that we can't get a du over u here. However, we do have a monomial denominator. So I can split this up and say this equals 3x over x squared plus 7 over x squared times dx. And then if I simplify that up a little bit, I get 3 over x plus 7x to the negative 2 dx. So now that equals 3 ln absolute value of x, because it's 3 over x, and it's basically, you could take the 3 out front if you wanted to, but it's 3 times the ln of x, plus, and now if you add 1, you get -1, divide by -1, it's going to be negative 7x to the negative 1 plus c. And if you want to, you can rewrite it. It doesn't really have to be, but 3 times ln of absolute value of x minus 7 over x plus c. Either answer is fine, but there's your antiderivatives. And you can see there's a lot of things you have to learn here, and you're going to need a lot of practice. So, and you'll have an opportunity to get a lot of practice. And here comes some more. We have 1 over x squared plus 1. Hopefully you just look at that and you say, oh, I remember that. We know the derivative of inverse tangent is 1 over x squared plus 1. So that's just going to be inverse tangent of x plus c. Now the next one, and this one is pretty tough, because you look at this and you say, what in the world is this going to be? Well, let's just take a look. You look at that on the top and you say, I don't know about that. And obviously the top's not the derivative of the bottom. We have 1 plus x to the 8th. Well, that's kind of like this 1 plus x squared, only it's really 1 plus x to the 4th squared. So what you have is this x to the 4th is like a u. And so if I say that u is x to the 4th, then we know that du dx is 4x cubed, or in other words, du equals 4x cubed times dx. Well, that's almost what I have. And I can easily make it 4x cubed by just multiplying it by 4. Well, of course, you can't go around multiplying things by 4 without changing the value of them. And of course, that 4 could be pulled around front if I did put it there. But we can't just multiply it by 4 unless we also multiply it by 1/4 to cancel it out. But what I now have is, let's take a look. I have 1/4 times the integral of, if I let u be x to the 4th, that means it's 1 plus u squared on the bottom. And 4x cubed is actually 4x cubed times dx, right here, 4x cubed times dx on the top is actually my du. And so this is really 1/4 times the inverse tangent of u plus c. But you can't leave your answer like that. You have to change it back into x's. So it's 1/4 inverse tangent of, and what was u? It's x to the 4th, so it's inverse tangent of x to the 4th plus c. Now, you don't have to change it to u's. If you can just look at this and see it, then you can go right to your answer. All right, and that's just, this is hard for a lot of kids. It's going to take a lot of practice, a lot of work to start to see this. But once you do, it becomes pretty easy. Or it gets easier at least. Okay. So on the bottom one, we have 1 plus x to the 8th. We have x to the 7th. So you might be tempted to do something similar to this one, except the bottom is just 1 plus x to the 8th, the whole thing, and then the derivative of the bottom is 8x to the 7th. So that's real easy to make the top an 8x to the 7th. I just put an 8 there and a 1/8 out front. And now I have 1/8 times the integral of du over u, which of course is just 1/8 times the natural log of the absolute value of u plus c. But because we can't have it in terms of u, it has to be in terms of x. It's going to be 1/8 natural log of 1 plus x to the 8th, and then plus c. Just substituting in what u was, and there we have that one. All right, not so easy, but I think you'll get the hang of it if you keep working at it. And we have even more. You're kidding me, right? Nope, and there's even more. What's the integral of e to the x dx? Antiderivative is just e to the x, because the derivative of e to the x is e to the x. So now it's e to the 3x. So again, I get to sometimes using the u substitution, which we really don't learn until chapter 6. So you could just look at this and say, okay, I know the derivative of e to the x is e to the x, so the derivative of e to the 3x is going to be e to the 3x. But if you took the derivative of e to the 3x, it would be e to the 3x times 3. And since there's no 3 there, I'm going to need a 1/3 here to cancel it out when I take this derivative. When I take that derivative, the derivative of that is going to be 1/3 e to the 3x, chain rule times 3, and the 3's cancel, and then you're left with just this e to the 3x. So I have 1/3 e to the 3x plus c is my answer. Now, if I do use the u substitution stuff that you're going to learn in chapter 6, since it's not plain old x, I can say u is 3x, and du dx is equal to 3. But if I just say du is going to be equal to 3 times dx, multiplying both sides by dx. So what would be the integral of e to the u du? Well, we just know it's going to be e to the u, right? Plus c. Well, we don't have an e to the u du, because if it would be, this would have to be e to the u, which is 3x dx. The u is 3x. And then du is 3 times dx. So you literally would have to have a 3 right here, so it would be 3 times dx. But if you put a 1/3 out in front of that, now you do have 1/3 times e to the u du. And of course, that's just going to be 1/3 e to the 3x plus c, which is the same thing. And you don't have to know it that way. I just thought I'd throw that in here right now. Again, you can just kind of figure it out. We know the antiderivative of e to the 3x. We know the derivative of e to the 3x is e to the 3x times 3, so you just have to have that 1/3 right here in order to cancel out the chain rule. All right, let's look at the next one. So the next one is 3 to the x. Well, we know that the derivative of 3 to the x is equal to 3 to the x ln of 3, right? So if I say the antiderivative is 3 to the x, when I take the derivative of it, I'm going to get an ln of 3 there, which I don't want. So what if I say the antiderivative is 3 to the x over the ln of 3 plus c? Now when I take the derivative, that chain rule ln of 3 will cancel out with this ln of 3 right here. So when I take the derivative of this, since this is supposed to be the antiderivative of 3 to the x, when I take the derivative of this, it should equal 3 to the x. And it does, because you basically have a constant 1 over the ln of 3 times 3 to the x, and the derivative of that is equal to the constant 1 over the ln of 3 times the derivative of 3 to the x, which is 3 to the x times the ln of 3, and the ln of 3's cancel, and you're left with the 3 to the x. So that is how you can do that. And I'm not going to go into the u substitution thing on that one, so we'll just leave it at that for now. And the last one, you look at it, and that should be one that you just recognize right off the bat. And this last one is going to be the inverse sine of x plus c, because the derivative of inverse sine is 1 over the square root of 1 minus x squared. So that takes care of that page. Let's see what's next.